All right, how's it going, everybody? This is the Conscious Bodybuilding Podcast, episode number 27. Today we have Dr. Gabrielle Fundaro on, and we really just wanted to talk about the gut microbiome and get into some of the actual more practical things surrounding gut health, because I have Matthew Bolino on, a returning guest as well and co-host, and we both kind of have this gripe where we see a lot of like nebulous terms getting thrown around. We really just wanted to get into the nitty gritty with her of like, what does all this mean and what can we actually take away from our current understanding of the gut microbiome. So thanks, Gabrielle, for coming on. Could you briefly start by just introducing yourself and how you got interested in this field of study?
Yeah, absolutely. It was actually sort of a series of serendipitous events that brought me here, and I can't claim any credit for having gotten myself here on purpose. But for those who aren't familiar, I'm Gabrielle Fundaro, known on Instagram as Vitamin Ph.D. I have a bachelor's in exercise science and a doctorate technically in human nutrition, foods, and exercise. But my dissertation project focused on the effects of probiotics during high-fat feeding. The reason that I focused on that was that my actual project, the one that I intended to study for 4+ years, that was on high-fat feeding and hypertrophy. We did 6 months of like solid animal husbandry, and it was just seamless, went off without a hitch, collected the tissues. We lost no mice, which is almost unheard of. And then there were some errors in the way that the samples were stored in the fridge. For those of you who aren't familiar, there are certain substances you might use in a lab that remove Sharpie very easily. And so we lost the vast majority of our skeletal muscle samples. And so we weren't able to do pretty much, the brunt of the project that was intended. And thankfully, I had a side project that was supposed to be just a support of mice using a VSL3 probiotic blend and to determine if there was some protective effects during high fat feeding. And so my PI said, well, I guess this is going to be your main project now because, we're 6+ months in and it would suck to have to start over again. And I had been kind of curious about that anyway, because one of the models that we were using was a model of metabolic endotoxemia. So we would inject mice with something called LPS or lipopolysaccharide, which is sort of, you can think of it like a toxin. It's something that can cause some inflammation in the body. And it comes from certain microbes in the gut. And so I was wondering, if we know that this is something that could potentially be occurring in human beings, why aren't we looking sort of at the source? Why aren't we looking more into the gut microbiome if we know that that's the source of this LPS? And maybe we can mitigate it there rather than trying to treat the downstream effects of, insulin resistance. I had been asking about that for several months, and that wasn't our focus in the lab, and we didn't have funding for that. And then when funding became available, then I was able to take that project on. I didn't have any intention to go forward in that area of gut microbiome science. I wanted to teach, and so I was hired into an exercise science department, and I taught for 4 years until I decided to resign and go into self-employment and coaching and speaking. And it was actually Mike Israel's idea to go on to podcasts and try to communicate the science, communicate gut microbiome science in a realm that at the time was really just rife with a lot of misinformation and unscrupulous marketing. And so that's how I ended up here.
Yeah, wow, that's a cool story. It kind of like wasn't intended. It kind of just it kind of fell into your lap, so to speak, right?
Mm-hmm.
Yeah, that's
Yeah.
really cool.
Yeah.
I wanted to comment on that. I feel like a lot of the marketing like still exists. Like I still feel like I get YouTube ads for like some of these products, where it be like a greens powder or like a probiotic supplement talking
Mm-hmm.
about dysbiosis or this or that. And it's always so cringy because I'm like watching like a really good like podcast or interview with somebody, and then this like ad comes on. So I think it's still something that exists, and it is important to have these discussions, because as much like my idea with even doing this podcast is just to have to contribute at least in a positive manner, because like there's so many voices with spreading misinformation. Like you could sit around and talk down about all of the people putting out misinformation, or you could contribute in a meaningful way, and I think that's what I try to do. But so I wanted to get some definitions down. So if you could talk to us a little bit about what the gut microbiome actually is, first and foremost.
Mm-hmm. So the gut microbiome essentially refers to all of the microbes and the genetic material that reside in your small and large intestine. So the vast majority are bacteria, and that's what people are usually familiar with when we say microbiome, or when we say probiotic. They understand that there are bacteria there. We have other types of organisms there as well. It's actually we have representation from like all domains of life, which I think is really cool, because we have archaea in there. We have fungi like yeasts, and we also have and those are eukaryotic cells, just like we would have in the human body. And then we also have viruses that can affect human cells, and viruses that can affect bacteria. Those are called bacteriophages. So we have this ecosystem essentially that lives in our intestinal tract. They interact with one another, just like organisms on planet Earth that we would see interacting with one another. They compete for resources, just like the organisms that live on planet Earth that we can see. And they vie for real estate too. So they're in collaboration and in competition with one another. And so it's a difficult thing to study and to really parse out causal relationships, because even if we see that some intervention causes an elevation in a certain group of microbes, we really can't determine whether it was a direct effect of whatever the intervention was, or if it was a downstream effect that resulted from another group of microbes that was potentially interacting with the group of microbes that we studied, but we didn't see the other interaction because we weren't looking for it.
Yeah. Wow. It is really complex to think about. I don't know why that when you spoke specifically, what's that movie with Bill Murray and I think Chris Rock as well? Oh man, where you guys don't remember that movie?
Bill Murray, maybe. I'm thinking of
he
Chris
eats an
Rock.
egg and he gets sick, and it's like it's animated.
Oh, Osmosis Jones.
Osmosis Jones, yeah. That made me think
Whoa.
when you're talking about competing for resources and stuff. I just thought of that movie right now. That's like a really good, like I mean, I don't know if it's a good analogy, but that just made that kind of competing for resources and just kind of like having these interactions inside our body.
Yeah.
I don't know how much relation that actually has, but yeah, that's really cool, and it is really complex. What can we really like? I don't want to make this too broad. Like, as far as the gut microbiome, what are some like definitive things we do know as far as like the effects it has on the body? I know that might be broad, and if you want a more narrow question, I can definitely narrow it down.
Well, I would say I'm very conservative about using the term definitive because the field is so young. I mean, really, I want to say I believe it was Connie that cited that since 2015 or so, maybe, or a little bit earlier than that, there have been about 50,000 publications. So there's been exponential growth in the field, but with that growth comes a number of limitations and a number of kind of just problems that researchers are aware of. And there have been publications of just kind of initiatives, things that need to be addressed, like consistent definitions. When we say dysbiosis, that has like 12 different meanings. When we say eubiosis, I mean, we don't really even have an established healthy model to which we can compare our microbiomes. yeah, we do see that there are some patterns where there are some microbes that might be over or under represented in certain diseases versus a healthy person. But we really don't know that those are playing a causal role. And it could be that that's that person's healthiest possible microbiome. It's adapted to the stressors of its environment. And we still don't know whether the microbes are sort of initiating a disease process or if the progression of the disease is having an impact on the microbiome. So the best that we can do in terms of coming up with something that's definitive is, I think, combining just the basics of microbiology and the mechanistic data that we have from our in vitro and our animal models, and compiling that with observational studies that we have, when we're just looking at huge cohorts of people and we're saying, like, what are the lifestyle habits that seem to correlate with what we think are good things right now, like having an abundance of butyrate producers. And then from there, we can come up with pretty soft recommendations that might change. They're flexible, but we really can't establish cause and effect relationships between the gut microbiome and any outcome, in part because the microbiome is so incredibly complex. And there's a chance that we may never establish that. We may never be able to say this whole microbiome, all tens of trillions of microbes, caused this one specific outcome. I mean, it's just not plausible. Yeah. We may be able to eventually start drawing causative relationships between certain microbes and certain disease progressions, but that's really a long way out also.
Yeah. Well, I think that's really important that you even touched on that because like you mentioned earlier, it is a still emerging field, and there isn't, like you said, we can't really say, oh, because you have this population of bacteria, you have this, right? I think one thing that I've seen is that we do see kind of correlations with certain, like you mentioned, certain disease states. Mm-hmm. Like if someone has tends to be maybe have metabolic dysfunction. I think I've seen some stuff on that where they have a certain population of certain bacteria. Could you maybe talk about some of that where we do observe some of those disease states and some of the changes to the populated bacteria and other things in the gut microbiome?
Yeah, I love this question, and it actually brings up a fairly recent shift in like the widely accepted beliefs in the gut microbiome science community. So in the 20-teens, there was the idea that individuals could be broken up into enterotypes. So sort of like somatotypes, where like you're an ectomorph or you're an endomorph, and that's been debunked. The same thing happened with the enterotypes. So back in the day, they thought that if you had a lot of Firmicutes, we're looking at a very zoomed out view. This is like the phyla level. It's like comparing vertebrates to invertebrates. So you could think like, oh, if you have too many vertebrates, then this thing is going to happen. So too many Firmicutes was considered to be obesogenic, and they were associated with metabolic dysregulation. But Bacteroidetes was associated with leanness. Now, the issue here is that when we break down all of the different species that are in a phyla, is a huge, huge number. And so, and even within, a species, these subspecies or strains can have different behaviors. So E. coli nissile is a specific strain of E. coli that is probiotic, whereas other strains of E. coli, we're familiar, cause really severe disease. So even though there's a bunch of E. coli, we can't say that like, oh, E. coli is a bad bug. So that was the issue back then. So they tried to kind of classify people as being, having more Firmicutes, more Bacteroidetes, and I think the other one was like having an abundance of Roseburia. And then tried to correlate, their phenotypes. But over time, they started to realize like, oh, wow, these are far too general classifications. And actually people have a lot of lactobacilli and are not necessarily developing obesity because of that. So I just like to point that out as like something that was fairly recent, and people thought like, yes, this makes a lot of sense. There are enterotypes, and now we can start saying like, oh, if you have too many Firmicutes, then this is going to, increase your likelihood of developing obesity. And that wasn't the case. And they've done the same thing too with trying to establish causal relationships between, I think like Prevotella and Akkermansia are two sort of like interesting case studies, where they were looking at different strains of Prevotella, and they were really confused because it seems like sometimes people who have a disease have an abundance of Prevotella species, but then in other cases, people who are really physically active also have an abundance of Prevotella species. And then it's like, oh gosh, well, are these good or bad? And so, it really is based on the context of the entire microbiome. And so that's where we can start thinking about, instead of just looking at like one microbiome and being like, this is just one big unit, that we can start to look at it in terms of its functionality. So there's a functional diversity where we can look at the number of different genes that are present in a microbiome, because that indicates what it can do and what kind of niches it can fill for us. The things that we're not, like our organism can't do, but if we are a supraorganism in which, it's us and our microbiome, that we're capable of doing more things. So we have that level of diversity. And then we can also just look at the taxonomic diversity, just who's there. And we can evaluate the microbiome in that way to say who's there, and then like what is the capacity of this microbiome, and realizing that who's there will to some extent influence what they're going to be doing. So for example, potential pathogens are normal inhabitants of the gut. So C. difficile, for example, and like Streptococcus, like some of these bugs that could cause disease won't, because they sense their population, and they can sense like the population of other microbes through something called quorum sensing. So they're kind of getting an idea of like, how many of us are there and how many of these others, and like what's going on with my host's immune system. And they're not going to exert the energy required to start producing virulence factors unless they are going to be able to like get something out of it, because that's metabolically expensive for them. So as long as the relative abundances, the ratios of microbes are in balance, and that's a very subjective term that hasn't been defined yet, then our microbiome will sort of behave. You can think about it like that. Our microbes will behave. But the issue is that we haven't established like what the balance is supposed to be, the reference ranges. So when people are looking at something like a GI map, or like one of those similar, comprehensive stool analysis tests, and they see, oh, this reference range, so I have too much or too little of this microbe. That's not based on any sort of research consensus. That is based on the manufacturers of that test having compared your microbiome to a cohort of healthy individuals that may not truly represent what would be expected for you. And so you're labeled with dysbiosis, or you have too much of one thing and not enough of another. And those reference ranges look scientific, but they are pretty arbitrary.
Yeah. One thing I want to mention is I'll definitely say too, it's nice to see that I think a lot of studies, especially recently, a lot of these studies are, instead of looking at like the taxonomic abundance and what's there, they're starting to metabolically profile the metabolome, what those bugs are doing. And there's a recent paper that just showed formate, especially in infant gut, like there's cases where the taxonomic abundance, even the taxonomy in general, is completely different, but the linkage to diseases are completely linked to the metabolome, what metabolites are being produced by these bugs. And it's such a, as you said, it's so complex. It's a huge ecosystem of this, microbial community that takes into so many factors, like the temperature, the pH of the gut, all these factors. And I think another common thing is people get confused when they talk about the microbiome. They're specifically referring to the microbiota itself. So then there's a huge kind of disconnection where people are like, oh, the microbiome, what's there versus, well, what is it doing in terms of like an actual community itself, So. Oh, yeah. Really cool stuff. But
yeah, it's that problem of definitions, because it happens in publications too, and saying gut microbiome or gut microbiota when it's actually just the fecal microbiota or microbiome.
Right. Same thing with the probiotics, constantly being redefined. Well, what is a probiotic? What is a prebiotic? Even dysbiosis. I mean, dysbiosis as a term is just it's almost like, what is, like, the specifics of dysbiosis is totally unclear, unbalanced what though,
Yes.
So it's another thing.
Yeah. There is one of my favorite publications. I think it's Olison. I think it was in 2016. And it's titled Dysbiosis is Not an Answer. And he basically lays it out. He says, dysbiosis is a non-answer. It's a scapegoat that we can use when we don't know what's going on.
No.
We can say,
Yeah.
Dysbiosis.
Yeah. Right. Something there's not balanced. We don't know. Yeah.
Which goes to like the problem of like, say, a coach-client relationship where you label someone having a problem, or even in marketing where you label someone having a problem, and then here's the fix, right? Here's something I can give you. Here's a pill, a probiotic or whatever. You have dysbiosis, give you some random probiotic to give you a certain amount of bacteria that we have no idea. Like I was talking with Matthew before this, like did your coach do like a fecal sample and then like maps out,
right? Sequence
if they were able to, would they be able to extrapolate anything practical from that? And I would think probably not in most cases. So yeah, I kind of wanted to talk a little bit about that. Is there like, as far as probiotics, is there any let's say like a need for them? Is there a way to assess a need for a probiotic, and is there utility for supplementing with them?
Yeah, actually, I used to be much more skeptical across the board about supplementation. Even having, used probiotics for my dissertation, like it wasn't that I was a strong believer in their utility, but it does look like there are a handful of probiotics that are useful for specific applications, but their efficacy is really strain specific. And so it doesn't make sense if you are a healthy person, then you have no GI issues and you don't anticipate having any sort of travel or anything crazy coming up, to take just a random blend of probiotics like a multivitamin each day. And really, and even like to the point of about, doing a fecal sample test before and after. It is very likely that after taking probiotics, you will have an enrichment of those probiotic strains in your fecal sample. That does not mean that they have actually enriched or taken up residence along your intestinal tract. And also, we don't know whether they actually need to do that for them to exert. So just so that people understand like the level of uncertainty that we have about how it works, and even if they need to be alive or not. But so if you've gone, if you have done the before and after and you're thinking, well, actually no, I did have more probiotic strains in my fecal sample afterwards, that totally makes sense. If you eat a lot of fermented foods, you'll see the strains from those ferments in your fecal sample. If you eat a lot of bread, you'll see a lot of yeast DNA in your sample. So your fecal samples do represent whatever microbes you might be ingesting, but a fecal sample is significantly different from what we might collect in the more proximal part of your colon, like close to your small intestine, or what we collect in the small intestine, and even what we would collect from like scraping the mucus from the inside of your intestinal wall versus getting it from like the lumen, the tube. So just so that people are aware that, the probiotic research is still in need of standardization, and we still have a lot of unanswered questions. But in terms of what we have seen from interventions, where we have a person who has diarrhea and then we give them a probiotic, and then we see like how long does it take your diarrhea to clear up versus a person who didn't take this probiotic, that there are a few that might be helpful in treating traveler's diarrhea. So that's when we're traveling and we get some kind of bug from, a lack of food and water hygiene. Antibiotic associated diarrhea. So that's just how it sounds. It's what we would develop while we're taking antibiotics. And in a number of other diseases like IBD, so inflammatory bowel disease, irritable bowel syndrome. There might be some assistance with preventing C. difficile from coming back after it's been treated. But, like I said, it's very strain specific. So for example, if we have pediatric diarrhea, there's a specific strain, Lactobacillus rhamnosus GG, that is effective for pediatric diarrhea, not effective for adult diarrhea. But in adult diarrhea, we see that S. boulardii, which is actually a yeast, is really effective for assisting with adult diarrhea associated with traveling or antibiotics. So yeah, if someone tells you like you should be taking a probiotic every day, that's really sort of a nonsense statement of like, why and for what? If I'm a healthy person, why do I need to be taking a probiotic?
Yeah, no, that's really
and
cool.
It's so funny because I've noticed that most people, a lot of people do that, right? Where they're like, oh, gut health, I got to go get my lactobacillus or something, and they're healthy individuals. It's like most likely you have the strain or,
Right. Right. And I think a lot of the time they miss the bigger pillars that they have a little bit more control over, right?
Right.
Like I always think of something like making sure you're eating enough fiber and looking at certain foods in your diet first before going straight for the pill or supplement, right, to kind of mask the issue, even if it does. It is really cool that they do have some case specific utility though as well. So they do have that. What was that? One thing I wanted to mention when we were on that. I totally forgot it. Well, I guess as far as that goes, I really wanted to talk about the utility of fiber in the diet. So, like, how important is it for us to consume fiber for our, for lack of a better term, gut health and overall health as well?
Yeah. If you ask a carnivore person, they'll say not at all. It's not important. It's probably harmful. Probably hurtful.
Quadruple.
Fiber? What?
Yeah, we don't need fiber. So I'll give a little bit of a working definition of what I am talking about when I say gut health. So I just call this like the 3 Ds of gut health. So we have digestion, and that can be both the objective process of digestion, like are we lactose intolerant or not? Because if we are, that means that we're not producing the lactase enzyme, and so we can't break down the lactose sugars, and that leads to a subjective experience of feeling bloated and gassy. And so we're kind of like, ooh, my digestion isn't great. And then the next is disease. So that's either the management of the symptoms of a disease. So inflammatory bowel disease, that means that we're going to be having some ulcerations or some like chronic inflammation that's damaging the lining of the intestine. Or if we have irritable bowel syndrome, then we're going to be, our intestine looks normal, but we have a lot of the abdominal discomfort and bowel irregularities. So can we manage the symptoms of that disease? Or can we prevent the development of diseases later in life, like colorectal cancer? So we've got digestion, disease, and then the third is diversity. So diversity of the gut microbiome. And I say this like very, again, like very conservatively, because we don't know what the right level of diversity is. There are different ways to assess diversity. So there are kind of different metrics that researchers might use to measure the diversity of a specific population. And we can't make any guarantees that like, if you eat this one specific food or this specific dietary pattern, that it will definitely increase your microbial diversity. And that will definitely be a good thing. But we can say that there are some correlations between some dietary patterns and changes to the whole community and those changes might be associated with more positive or more negative health outcomes down the line. So for example, when we look at the link between red meat intake and colorectal cancer, that the microbiome probably plays a role in that, because if we have a lot of red meat, if we're eating a lot of red meat and we're not eating very much fiber, then some of those microbes that can make the switch will switch over to proteolytic fermentation. And when they do that, they start to produce compounds that are carcinogenic. And so there's where, we can say that there's a link there. But again, there's not a cause and effect relationship that's been established as of yet. So that's the gut health. That's the definition of gut health. We got the digestion, disease, and diversity. And so when we look at the effects of fiber, so fiber does play a role in terms of the digestive process. So we have soluble fiber that does not dissolve in water. We can think of like the fruits or the skins of fruits and vegetables. And then we have soluble fiber that if you were to add water to this food, that would get mushy. So something like oatmeal. And in most cases, we see that like foods have a combination of both soluble and insoluble fiber. So insoluble fiber can help to create bulk in the stool. Soluble fiber also can contribute to stool mass. Soluble fiber is almost like, I don't know, like the opposite of Goldilocks. Like it actually can help whether you're constipated or you have loose bowel movements, because it helps to, it attracts some of that excess water. Soluble fiber is most often also going to be fermentable. So that means that fiber, both kinds of fiber, they bypass our digestive processes. So our digestive enzymes can't break them down. So fiber reaches the large intestine, and that's where most of our microbiota live. And most of them, especially when we're looking in like the distal large intestine, when we're looking in the colon, they're obligate anaerobes. So they don't do well around oxygen. And so that means that they're producing their energy anaerobically without oxygen. And they have a heavy reliance on glucose to do that. And so they're getting that from these dietary fibers. Now, in the process of fermenting those dietary fibers, they could be producing some helpful products. We call these postbiotics. So like a short chain fatty acid, like butyrate. Butyrate is used by intestinal cells as an energy source, and it's also associated with like markers of metabolic health, so insulin sensitivity and appetite regulation. We see that people who are really physically active tend to have a lot of butyrate producers in their guts. But they can also produce gas, and that can make us feel bloated and uncomfortable, especially if we have something like IBS, where we're extra sensitive to those sensations and we feel like that's kind of painful. So some of these fermentable carbohydrates, they lead to that gas production. Some of them also attract a lot of water into the intestine, and so they can lead to loose stool, and that can be really uncomfortable. So fiber has an effect on our digestive process, and it also influences the microbiome. And it probably also serves a role in terms of like overall general health, if we're thinking about like its ability to attract excess cholesterol that we've ingested, and helps us excrete cholesterol. So like it could even help with cardiovascular disease. The other potential effects of eating fiber is that the microbiome can produce other beneficial postbiotics that might serve a protective role against colorectal cancer. And quite often when we're eating these high fiber foods, they're from plants, and we're also taking in phytochemicals. And those can also be metabolized and also result in the production of products that probably protect against colorectal cancer. So when we look at a person who's eating a westernized diet that's really low in fiber, high in refined carbohydrates, sodium, added sugars, saturated fat, red meat, and we compare that to something like the Mediterranean style diet, or other prudent diets like the dietary approaches to stop hypertension, there's actually a pretty sizable change in colorectal cancer risk later in life, like upwards of about 20% lower risk in people who are eating a more prudent dietary pattern. So that's just to say, like, if you're not getting adequate fiber, you may short term have uncomfortable bowel movements. You may be, for lack of a better term, kind of starving some of those microbes of their preferred energy source. And then later in life, you could potentially be increasing or not reducing your risk of developing colorectal cancer.
Yeah, Sonnenberg over at Stanford has a beautiful study. It actually shows too that if you're like not eating enough fiber, or let's say you actually just totally don't eat fiber at all, the microbes have to shift to a different source of energy. And what they're doing is they're eating the glycans that are found on the mucus. So what's literally protecting the host epithelium from the microbes, the whole microbiota, starting to eat at that lining. And eventually now you have all these gut issues where, oh my God, you have inflammation, and that's due to these bacteria getting too close to the epithelium. And, it's kind of crazy, it's like, whoa, it's almost like we've adapted. And that's like the mucus that's found in our colon, 80% of it is glycans. So the source of, carbohydrates for these microbes. It's almost like we adapted and like evolved with these microbes and to produce these like glycan structures on the mucus, which is, that could also be scary. You don't eat your fiber, man.
Oh yeah, absolutely. I think that's actually where they found some like conflicting results with Akkermansia, eosinophilia, because it's a mucus integrator. And so, if you're feeding it enough, it's kind of like, oh, it's great. It's a happy little microbe. But if not,
right,
it's going to be degrading those.
Gets a little angry. Yeah.
Yeah, exactly.
Yeah. I will say it in, oh, go ahead.
Oh, no. It's kind of a follow-up. I'll let you go first, because I think this is a good segue.
I was just going to say, observationally, I do notice that while a lot of people will talk about some of the issues of high fiber intakes, like going too high in fiber and being bloated, I've seen people have digestive issues being too low in fiber. And I think that kind of goes along with what you're saying. And it's really interesting. I when you were talking about high fiber intakes offsetting like the effects of like red meat intake, I think I'm familiar with some of those studies, but I think that's really interesting that we also see a shift in certain bacteria when that occurs, right? And how that offsets some of the risk potentially of cardiovascular disease, right? Of having that higher fiber intake.
Yeah, that was that classic. But I don't know if you're familiar with like the Turnbaugh study. So that lab.
Peter Turnbaugh. Jeff Gordon's lab. That's like a really well-established lab.
Yes.
That lab is no joke.
I know, that was the lab. So for people who are not familiar, that was the lab that like first used fecal transplants to transfer an obesogenic phenotype from one mouse to another. And they've done some of the really groundbreaking studies on the effects of dietary pattern and the microbiome. And they found in humans that if you have people eat an all animal product diet, like just meat and cheese, that you see a really significant shift in certain communities, certain groups of microbes, certain taxa within 24 hours. Now, one thing that I found that was kind of entertaining is that there were some proponents of the carnivore diet that cited this Turnbaugh study and said this all animal product diet increased diversity. And, and then the people who ate the vegetarian diet, they didn't see an increase in diversity. And I thought, mechanistically, that doesn't make a ton of sense. Let me dive in and let me look at this paper. Well, actually, it was beta diversity, and beta diversity is it's a comparative metric. So it's like how similar or dissimilar is this community from this community. So when we see a high level of beta diversity, it means that there is a big difference or there was a big change from baseline. So that's actually what they saw, that the people who ate the all animal diet were significantly different after their microbiomes were significantly different after 5 days of the all meat diet, whereas the people who were eating the vegan diet, their microbiomes remained pretty stable. And what they found is that in the people who are eating that all meat diet, sort of it makes sense mechanistically, and it's sort of predictable that there was a reduction in microbes that are really reliant on our dietary fiber, like bifidobacteria. And then there was an increase in those that can engage in proteolytic fermentation, like Bacteroides, or those that can degrade the mucus layer as well. So those mucus integrators. So it's, again, just these microbes are just adapting to the environment, like what nutrient is available. Okay, the ones that can live on that will thrive, and we'll see their relative abundance increase. And then the relative abundance of the others will decrease because they are dying off. They're not receiving the nutrients that they need. And so it wasn't, and not necessarily to say that like a beta diversity is a bad thing. Like changes aren't necessarily bad, but when we're seeing like, qualitatively, how is it changing? And then what do we know about like the links between these microbes and like the products that they're creating and the link of those products to disease outcomes? Then we would say, okay, in this case, the changes probably weren't great. And it would be inaccurate to say that like, oh, this all meat diet increased diversity, because it's like, that's the wrong kind of diversity.
Right. Did they show the alpha diversity in that study? I figured that alpha diversity was relatively low in the carnivore diet.
I can't remember. Yeah. I don't remember if I'm sure that they probably did look at alpha diversity, but I just can't recall. I just remember like seeing that beta diversity thing. And I was like, oh my gosh, this is a total like misrepresentation of what's going on here. But it was just sort of funny, because it was like, if you didn't dive into it and understand the difference between alpha and beta diversity, it would be like, oh my gosh, well, more diversity, that's a good thing.
Right. I feel like a lot of studies too in the gut microbiome are able to manipulate statistics, or might not use the best like statistical testing to actually look for, these things, which could also be, again, it causes a lot of, oh, well, I found this study that says this. And it's like, you got to really look at like the methods and like how they're statistically testing for these things to draw these conclusions,
Yeah, absolutely. Yeah.
Yeah, I think you see that a lot with either side of, or people who belong to diet tribes a lot of the time, as they pick certain cherry pick certain studies and try to represent or misrepresent the data to kind of confirm their bias. One thing I wanted to mention, so I coach bodybuilders and also just people who want to get in shape and stuff like that too. But I one thing I see a lot just across the board is lower fiber intakes. I wanted to talk specifically, and this is probably more of a niche subgroup, but of bodybuilders trying to increase their food volume. I think I hear a lot that they have trouble getting enough fiber in, which, it makes sense, right? You having a large volume of food. Fiber tends to be very filling, right? So what are some things that you could potentially do to still get some of the fiber intake, but also get a larger food volume, and some other considerations for consuming large volumes of food as well?
And I've definitely heard kind of both sides, that it can be difficult to get adequate fiber. And then also that there are some people that are eating, really high volumes of fibrous foods because they're trying to like reduce their body fat, and then they end up having, severe GI distress, or they're trying to get a caloric excess, just only from like minimally or unprocessed foods.
Yeah, please touch on both, because the other extreme is getting really lean and eating a ton of fiber.
Absolutely. Yeah. So what's often happening when a person is having GI distress associated with too much fiber is that they're probably taking in a lot of the really fermentable carbohydrates. So we call these FODMAPs. So the effects of FODMAPs are they're dose dependent, and they're also sort of dependent on like your personal level of tolerance. So for example, if you produce the lactase enzyme, then you're going to tolerate lactose just fine. Whereas a person who doesn't produce very much of that enzyme, they're going to be lactose intolerant, and they're going to have GI distress. There are some FODMAPs that are just universally malabsorbed, because they are absorbed based on diffusion, like fructose. And so we don't have a way to just like actively transport it. And so if we already have a lot of fructose that's being processed in the cells, then the rest of it just is going to hang out in the lumen, and it's going to attract a lot of water, and then we get a lot of GI distress. And then there are others for which we don't have the digestive enzymes. And so those are going to reach the colon, and they're going to be metabolized by microbes there. And the microbes might produce gas, or they might produce short chain fatty acids. And that's probably going to shift based on like the environmental conditions and also the context of the entire set of microbiota. And that's not very well understood. So we can't like have an intervention where we're like, oh, we're just going to shape your microbiome so that like they're only producing short chain fatty acids and you don't get gas. Whoever comes up with that is going to be a bajillionaire. But we don't have that yet. And so we just understand the mechanisms that these carbohydrates attract water, and they're highly fermentable, so they lead to some gas production. What we don't want to do is go to the extreme and just say like, well, let's stop eating all plant-based foods. That's probably not the most prudent idea. There are more systematic ways of going about removing and then reintroducing and sort of like testing the level of your personal threshold of these different FODMAP groups, so that you can determine like, okay, I'm a little bit lactose intolerant, and maybe I don't do super well with mannitol. So I have to limit like the amount of mushrooms and cauliflower that I eat. But like I'm fine with galacto-oligosaccharides, so I can eat beans. So determining which of these fibrous foods you tolerate well, and and maintaining those in your diet. But also, we kind of get stuck, I think, thinking like more is better, and eat like massive amounts of every fruit and vegetable and whole grain and never eat anything refined. And that really does make massing almost impossible, and it can really lead to a lot of GI distress. So, definitely recommend trying to hit the recommended fiber intake, which is about 15 grams per 1,000 calories that someone is ingesting. So even if someone is like on a serious massing diet, they're eating like 3,000 calories a day, 45 grams of fiber is probably going to be pretty tolerable for most people. But if you're hitting that and then beyond that, you're feeling really uncomfortable, or you've noticed that like, wow, I'm up to maybe 75, 100 grams of fiber per day, and I don't feel that great, then maybe replacing some of those unprocessed products with something that actually is more processed and lower in fiber, especially around a workout, because there is mounting evidence that there are a lot of perturbations to the intestinal tract during intense exercise. And that could lead to some GI distress that could potentially be exacerbated if we have something in the gut that is like super fibrous and attracting a lot of water already. So that would be a good time to switch out and have like your refined carbohydrates pre and post workout, and bring your fiber down a little bit. The other option is to have liquid meals. So liquid exits the stomach more quickly than solid foods, especially, and it's kind of like based on the concentration, like the osmolality, but that can also be an easier way to get down like a high quantity of calories in something that doesn't feel as filling as like a big solid meal.
Quickly on concentration, is there an ideal concentration of a liquid if you're ingesting, like, say, a mixture of carbohydrates and protein?
Oh man, I mean, I can remember kind of in like the gram ratio. I don't remember the actual osmolality. I probably would have if I was still teaching, but I think it was like 6 to 8 grams of carbohydrate per 100 milliliters of water, like a 6 to 8% concentration of carbohydrate. And I think that the recommendations were something like a 1 to 4 ratio of protein to carbohydrates. So if take that for what it's worth, don't quote me on that.
Awesome. No, I know. I think a lot of the time I just have these as baseline numbers for like clients of like, hey, make sure you at least have it diluted in this much fluid, or you might experience GI distress. And then obviously there's going to be an individual response, like, hey, a little bit more if you're getting, getting GI distress, or a little bit less if you feel like you're taking down too much fluid. A couple things I wanted to touch on what you said, so that's really cool. One thing is like the FODMAPs, also certain volumes can also be irritating, I think, too, like a certain volume of a certain FODMAP. And one thing I've seen too is I've been a proponent of this for a while, because I think the first person I saw kind of bring this more popularity, I guess, in the fitness space was Stan Efferding, and he talked a lot about FODMAP. But I've also seen him, and we interviewed Damon McCune, who helped him design that. And I've seen both of them talk about how the FODMAP isn't like a sustainable, like you don't stay on the FODMAP diet. You reintroduce foods and you see how you, and I really like how you touched on that. You reintroduce foods and you see how you react to them. And for myself, like I did the same thing where I had digestive issues, went to a low FODMAP, low residue diet, reintroduce foods, and then in certain volumes, like I can have some broccoli when I'm massing and have some of this. Like I like Brussels sprouts. I'll have, make sure I just don't eat like a pound of them, right? So that's a really important thing, I think, is to pay attention to how those foods digest for you, but going for, like hitting your fiber target, like hitting your baseline level of nutrients, and then introducing some of these more processed foods is usually something I advocate for. But that's really cool. Is there any other like big pillars someone would need to focus on as far as like ensuring optimal digestive health, other than like fiber intake and FODMAPs too, I guess?
Yeah. I mean, there's definitely there's something to be said about stress management. There's some evidence that psychological stress is associated with worsening symptoms of gastrointestinal diseases. So inflammatory bowel disease, and irritable bowel syndrome as well. And there's some really, there are some interesting interventions using gut-directed hypnotherapy and cognitive behavioral therapy in improving quality of life and reducing like subjective symptoms, like subjective, like abdominal pain. People say like, oh, my disease doesn't seem to be as severe, even without any changes to the disease markers. So for example, if you were looking at, inflammatory markers in IBD, they're still going to be elevated, but a person perceives the symptoms as having improved. And it's probably a little bit more effective for something like IBS, where there's a strong gut-brain connection. There was a really interesting study that used either double-blind placebo or an open-label placebo. So that means they had one group that didn't know they were getting a placebo, and they had one group that did know that they were getting a placebo. And if even when they knew they were getting a placebo, they felt better afterwards, because the doctor said, this is a placebo. Sometimes people feel better when they're taking one. And so it's sort of like, it's just kind of interesting to think about that, like how your mental state can impact your subjective digestive process. So, as much as we can, kind of like stress management. Other things would be, if a person does have to take in a really massive amount of calories, it's probably going to be easier for them to eat smaller meals more frequently throughout the day. That can make things a little bit easier, because smaller meals also exit the stomach a little bit faster. There have been statements about like chewing your food a specific number of times, or like making sure that you're like back in a sort of like a parasympathetic state post-workout. You could probably still digest food even if you haven't chewed it into like a super fine paste. There are still mechanical digestion that happens in the stomach. They're still churning. You're going to see like maybe some pieces are going to come out of the end, like the coating of corn, and that was going to come out of the other end anyway. But there could be something to trying to wait a little bit after your workout, so that you maybe not so much for parasympathetic tone to kick back on, but like, are you trying to stuff your face like right after your workout with a huge meal, and you're still like breathing heavily, and you're still the blood is still shunted away to your skeletal muscle, to the working muscle, and that can actually delay gastric emptying. So it's less so about like ensuring that we're in a parasympathetic state and just kind of looking at like, okay, well, during intense exercise, blood's being shunted away. Gastric motility is reduced, gastric emptying time is increased, so food's going to stay in the stomach longer. So give yourself a little bit of time to chill out. And once you feel like, okay, I'm not out of breath anymore, I really feel like I've cooled down all the way, then you know that your digestive process is going to be pretty much back online. And also keeping that in mind too, with like ingesting food while you're exercising. I mean, that's a reality for endurance athletes, that there does have to be some amount of sort of gut training. So if a person is doing an intense endurance event, they're going to have to experiment with different types of food. And so that's a possibility too. And that's really where like those concentrations will come in and be of more importance.
Yeah, absolutely. The intra workout for bodybuilders, it's very limited application. I always say is like, your exercise should probably be a certain duration. You should probably be a certain level of advancement. And even then, maybe it's just a way to offset some of your calories. But if that's the most benefit, or if we're being conservative with the benefit it has. What was I going to say? Well, one thing I wanted to touch on was that I guess back on the fiber subject before we get you out of here, a lot of people will counter the fiber argument with, I'm taking a greens powder, or I'll get a fiber supplement instead. And I know that, I've heard a lot about it not having the same protective effects, but what could maybe be some of the drawbacks of going that route first before trying to increase dietary fiber from foods, fruits and vegetables.
Mm-hmm. Yeah. Well, one would certainly be that if we're taking in just one type of fiber, we could potentially be providing a preferred nutrient for just one or just a limited selection of microbes. So we don't yet know which microbes prefer which fiber types, but there is some evidence that if we've been eating a very low fiber diet, or with this intervention they reduced dietary fiber, that the reintroduction of different types of fiber do seem to increase certain groups and not others. So from that, we can say it's probably a good idea to take in a variety of different fiber types from a variety of different foods, so that we can maybe reduce some of the competition between microbes. Because if there's one group that can, for whatever reason, like access that more readily than another, then they could outcompete the other group. Not to say that that would necessarily matter, because if we're looking at it from a functional standpoint, that just means like probably another group will have the same function and fill that niche. But it's just something to think about, that like when we're using a fiber supplement, that's just, it's only going to be psyllium husk or, whatever. And then the other issue is, that we're also missing out on like the other micronutrients and the phytochemicals and whatnot that we would be getting from plants. We're not going to be getting that if we're taking just a fiber supplement. Now, we could potentially be getting that from a greens powder. So I wrote a piece for Barbend on greens powders, and like really dove into what are the ingredients usually in greens powders, and like what are the outcomes when we're looking at interventions where they've used a greens powder. Unfortunately, there really aren't any interventions that have used a greens powder, but we can look at the ingredients and see like, okay, they usually are using some blend of herbs and grasses. They're usually using dehydrated plant matter. So it's usually going to be some like blend of fruits and vegetables. They often will have some digestive enzymes that are added, and sometimes they'll also add a probiotic blend. So we've already talked about the issues with taking just a random assortment of probiotics. Digestive enzymes can be a little bit hit or miss too. So there are some that do seem to reduce GI upset after eating certain foods. So like lactase, taking the digestive enzyme lactase, that seems helpful. And then I think it's beta galactosidase, whatever is sold as Beano, that might be helpful for maybe about 50% of people. But again, it could be, is it a placebo effect? And then the rest, there's really no evidence for. And if we're taking them in a way that they're not protected from our stomach acid, there are a huge number of enzymes that just won't maintain their functionality once they hit the stomach. They're just going to be unraveled and then broken down like any other protein. So that's the issue with taking just like a random assortment of digestive enzymes. When we're looking at herbs, those are the most commonly adulterated supplements. So that means that they're most likely to have contaminants in them, something like heavy metals. And they're most often associated, they're also very frequently associated with hepatotoxicity. So, if we're like, I'm going to take extra greens powder every single day, like that's not necessarily going to be, super safe. And then finally, when we're looking at the effects of the dried fruits and vegetables, there's really only a number of studies that have been performed on one specific brand that uses a bunch of like a blend of dehydrated fruits. So some of the vitamins and minerals in those products are bioavailable. So that means like we eat them, and then like the concentration of vitamin C in our blood goes up because we've been eating vitamin C. But you could do the same thing with a multivitamin at probably like a much lower cost, or with actual fruits and vegetables at a much lower cost. Even when we see things like increased antioxidant capacity, that doesn't necessarily mean that we're actually going to have more antioxidant activity or that we even need it. Like if we're healthy people and we're exercising regularly and we're metabolically healthy and, we're eating a really varied diet already, we probably are not in a place where we're like, oh no, I don't have enough, catalase or glutathione peroxidase or something, and like I really need to take this in a supplement form. Like, no, you probably are controlling your free radicals just fine.
Yeah, Yeah, that goes into a whole another argument of people trying to lower inflammation through many modalities, whether it's mega dosing antioxidants or plunging into a cold tub or whatever it may be.
Yep.
All right, cool. Well,
I have a question.
Yeah, go ahead.
I wanted to ask one more just because I've seen, actually, I just saw recently Peter Turnbaum. I think it's had some, I'm not familiar with the data, but is there a big difference in terms of cooking vegetables and stuff in terms of fiber? Does that actually hydrolyze some of the fiber? Does it? I'm not familiar, but I was curious, do we see a big difference in terms of whether the fiber contents is reduced in vegetables if you cook it or pre-treat it or something along those lines?
Yeah, I know the research that you're talking about, and I know that they did see a difference between raw and cooked, but I don't recall whether, like, which one was associated with like greater levels of diversity. You know, because there could be some there definitely could be some breakdown like ahead of time, but I can't recall, but I can't recall why there was a difference between the raw and the cooked. And I don't recall whether that was in humans, because I know that there was a rodent component to that study. But you know, one thing that, you know, in terms of like being very practical, if you're eating raw vegetables and whatnot, that usually takes a little bit longer to eat, and you know, so and you expend a modicum more energy. You know, eating like very unprocessed foods versus like the ones that are super cooked down. But actually, cooking is one way that you can reduce the FODMAP content of foods. So that would be a little bit of a workaround, you know, if you like really like, you know, super boil your broccoli, or you get like canned beans, because those have been really heavily heavily processed, but you know, in a way like just to cook them and whatnot, and to like rinse them really well, then you'll reduce some of the FODMAP content as well. So that's one potential workaround, to cook your vegetables really thoroughly.
And you can reduce volume, like take 2 cups of spinach and cook it down to something so small.
Yeah, like that meme. It's like one leaf of spinach.
It's one leaf of
yeah.
That's so funny. And that's just a great way for to get vegetables in. Like I'll mash up some berries, I'll make like a jam out of it, get some fiber there, you know, whatever it may be. Or even I've actually, like, sometimes I have this food chopper, and I'll take like ground beef, rice, veggies, and I'll just mash it all in there, and it's just a way to get the food more palatable and get some more food in. But there's lots of tricks like that. Cool. Well, thank you so much for coming on. Where can people find you? What are some of the services you offer as well?
Yeah, so people can find me on Instagram at Vitamin Ph.D, and then my website is vitaminphdnutrition.com. I do provide gut health consultation and education. I always clarify that I'm not diagnosing anything, but for example, if you're wondering whether you need to take a comprehensive stool analysis test or an IgG food sensitivity test, or you just want to learn more about like what could be going on with your digestive process, then I help folks with that. And then I also provide lifestyle coaching. So I help people establish a relationship with themselves and their food that feels good to them and just helps them flourish.
Awesome. Yeah, guys, everybody out there listening, before you down a bunch of digestive enzymes and probiotics, maybe you should consider booking a consult with Gabrielle instead. Cool. All right, we'll let you get out of here. Thank you so much for coming on.
Thank you.